Alright, so in the first half of this video, in part one, we developed our hypotheses, conducted a preliminary analyses, and prepared our file for M+, and now we are ready to start evaluating our models, beginning with the CFA. So here we are in M+, ready to go. So we're going to go to the M+, drop-down window and go to Language Generator, SEM with missing data. So we can put our file name in here, which would be full SEM model example CFA. So we're going to be testing the CFA here. We can browse here to find the data file that we are using. I'm already right here in the correct folder. There's my full SEM model practice M+ file ready to go. Hit next. We don't need to worry about changing any of this. We can put in some random things here. I sometimes like to do this just to get the syntax started. So I have some that started. You don't have to do this. It doesn't make any difference. You can type it out simply and easy as well. So we're going to keep going and go ahead and finish that out. All right, now it started the syntax for us to help us with moving forward. So if you remember, M+ can't read very far out for some reason. That's just the way it was coded. So if you just take a random part here in the file name and just enter over, that will prevent you from having that problem, the same one we had last time in the last lecture I had done. So names are, this is where we're going to put in the variable names here. If we go over to our SPSS file, let me open that up. There we go. I can just copy and paste my variable names over so I make sure I have them in the right order and are named correctly. So I can just take all of these and copy and paste them over. Right, and that names are. So one thing I do like to do when I have variables that are on a scale is to keep them all on one line together or two lines a little indented in so that I can very easily see where my composite variables are or where my variables I'm using for latent factors are. It just makes it nice and clean. It makes it easy to copy things down into your syntax window. So I always suggest this. Obviously you don't have to do this, but it does make things easier when you're doing your syntax later on. The use variables we're going to take care of later once we know which variables we are using in the data set. And there's one more thing that we need to add on here. I didn't do this in the last lecture, but for this one I want to make sure I do this because we are using data that does have missingness in there. And so you're just going to say missing are all, and then in parentheses, -99, and with a semicolon. What this is saying is missingness are, and then for all variables is -99. So now M+ knows what the missing value is. Now we are ready to move on to our model. All right, so for our model, this is going to be pretty straightforward because we're testing our CFA for our two variables. So we're going to be testing our CFA for relationship quality and relationship engagement. I'm going to name these a little bit differently than I have up here. You don't have to do that. You keep the same name, but I like to not confuse myself. So I'm going to call this quality for relationship quality, and then for the other one, I'm going to call engagement, so parental engagement. So the relationship quality is, we're going to use that by statement to indicate that we're doing a latent variable. And I can just copy and paste down the 6 relationship quality items. And then I want to add this into my use variables because I am using those variables. And again, putting it on a new line just makes things a little bit cleaner for me visually and for me to see what's going on. And then parental engagement is the other one. So that's going to be these 5 here. And there we go. We now have our syntax written for our CFA. we have our two variables, our two latent constructs that we have named, and then, oh, I'm missing a by statement right there. So we have quality by our 6 relationship quality variables, and then engage by our 5 parental engagement variables. And for our output, we want to have our stdyx and mod indices 3.84, just in case our model fit doesn't look too great, we can check that out. All right, so we are ready to run this now. We want to make sure we save this first, make sure we're in the right file, and then we're going to call this, what have we been calling these things? Full SEM practice. We'll just do full SEM example CFA. All right, we are ready to run. Uh-oh, we got some warning errors. Oh, I see what I did. Oops. So if we look down at the warning errors, we can see that there's an unknown variable. It says unknown variable in a by statement, parental engagement 1. I forgot to add these into my use statement. There we go. Now we're ready to run. All right, so let's go ahead and check these results out. We have 2 warnings, one of which just tells us start with n plus 5, type equals missing is the default for all analyses. Data set contains cases with missing on all variables. And then it gives us information about the CFA here, or about, that we have 11 manifest variables and 2 latent variables. It gives us a covariance coverage, and now model estimation terminated normally. Fantastic. All right, and now we have our model fit information. So we're going to look at our chi-square for model fit. It is not significant. Again, we want this to be, it is significant. We want this to not be significant, but when we have lots of participants, we have about 1,000, it's almost always going to be significant. The RMCA is 0.04, and if we remember the RMCA, we want to be below 0.08. Under 0.05 indicates good model fit. So this one I'm pretty happy with, especially because the confidence interval is between 0.035 and 0.051. So even the confidence interval is staying under that 0.08 threshold. So that makes me really happy. The CFI and the TLI are both above 0.9. The CFI is 0.96. The TLI 0.94. I'm pretty happy with that. And then the chi-square, SRMR is 0.035, and that one, if I'm remembering right, we want to have below 0.10. Yeah, but below 0.10. So that one's good too. We have good model fit. So with this good model fit, this kind of indicates we're sitting pretty good, that these 2 latent factors work really well, and these 2 variables will work well as latent factors. We can go down here and look at the stdyx results, or actually let's go to the model results first. For the model results, remember that this is just going to be the values as they are, the unstandardized values, and then same here, and you can interpret these the same as you would with unstandardized regression results. And then we could go down to our stdyx, that's our standardized results. And this gives us our factor loadings. You can see in our first one here, so for relationship quality, we have quite a few that are below 0.6. We'd like them to be at least 0.6, but overall average is right around 0.6 to 0.7. Normally I'd want this to be better, but with the model fit being as well as it is, I'm happy with that. And engage, we can see, is also kind of in the same kind of boat. But I'm going to leave this as it is because I'm happy with the model fit. I looked at the correlations and also the Cronbach's alphas with these, and I was happy with those. And so I'm going to make a decision and say, I'm going to move forward with this. Remember, in SEM, we're in a new camp. We're not just in these hard or fast rules. 0.6 is where we'd like to be for all of these, or above, or 0.7, or at least on an average of 0.7 or higher. These are a little bit lower than that, but I'm happy enough with these to move forward, and I can definitely defend that these work well together if a reviewer gives me any issues. For the R squared, this just tells you how much percentage each variable accounts for in the model. We can see some modification indices. The biggest one right here is to create a with statement between these two parenting variables, and that will increase our model fit pretty substantially. At this point, I don't see it necessary to do that because our model fit is so nice. I don't want to create, or I don't want to put in some with statements, some correlations between error terms in the CFA unless I have to, because that can create some problems with identification. And so to avoid those issues, I'm going to leave it as is rather than trying to make this model a little bit more complex by adding these with statements. If my model fit was poorer, then I could make it, I would definitely go through with doing that. So rather, I'm going to leave it as is and say this is good, I like it. So now what we are ready to do, I'm going to go ahead and close that output window out. I'm ready to go ahead and do my full model. So what I can do here, I can keep everything I have here. I don't need to start a new file. I'm going to resave it, and now I'm going to say testing full model. I still need the syntax because I'm still creating my latent variables, and now I'm ready to create, and I can even, remember you can do make notes in here with exclamation points, so I can say CFA syntax, so I can remind myself this is the CFA syntax. And then here, I can say this is my model syntax. And I'm going to pull the model over here so we can look at the model while we create this syntax. And remember, we're going to write backwards, so we're going to go right to left. So we're going to start with negative child behavior. And remember, we're using the composite variable for this. So this is our negative child behavior here. So here, I'll pull these right next to each other so it makes it a little easier to see while we work on this. So we're going to add negative child behavior, and this is going to be on, so loaded onto, and we're going to go backwards, parental quality time, relationship quality, and parental engagement. So parental quality time is this variable here, qual time. And I want to make sure I add both of these also to my use variable so I don't make that same mistake again. Get rid of that on statement because they're the only two new variables I'm adding into this. So on quality time, and then our two brand new latent variables. So now we have negative child behavior, on quality time, relationship quality, and parental engagement. I can see here I might be having a problem when I get down because I have quality time and quality. So I'm just going to change this quality. Rather than calling it quality, I'm going to call it relay, let's see here, relay Q, relationship quality. So I'm just going to, let's see here, make sure I choose the right one. Just so I don't confuse myself when I get down, I'm going to call it rel Q and change what I'm calling it. I don't need to change anything up here in the use variables or names are because this is a variable I created within my CFA. So now what I can actually do then, because our next one is going to take parental quality time on these two, I can just copy this out and paste it in and put on my on statement and my semicolon. And now my model is ready. I am ready to go ahead and run this. I have my CFA syntax here for my two CFA models. I have a negative child behavior on my 3, so that takes care of this arrow here, and this arrow here. And then I have quality time on rel Q and engage. So there's quality time on rel Q and parental engagement. All right, so we are all ready to go on this. So now we can hit run. Now before we do this, I'm going to tell you moving in that we're going to have a problem here. And it's going to be related to something I said, let's just skip over for now. And I did that purposely so you could see what happens when you don't pay attention to those issues. So I'm going to go ahead and hit run. And as we go down, we get the same kind of warnings we've gotten before. But now there's our covariance relation matrix, and then no convergence. Serious problems and iterations. Check your data, starting values, and model. So the reason we are getting this, if you remember way back when we were looking at our correlations table, we found that there was a pretty high correlation between two of our variables, specifically between quality time. Let me bring the model back over here. Specifically, we saw that there was a significant problem between parental quality time and relationship quality. We found that these two variables had like a 0.91 correlations between the two of them, and that could indicate some real problems with multicollinearity. Now, I said for this example, we're going to go ahead and continue on, and I did that purposely because so you can see what would happen if you don't really check your assumptions. Because we are doing a lot of regression here, and although we made a latent construct between these, the underlying issue is the same, that parental quality time, the variables that make this up and the variables that make up relationship quality time are very similar, that they're almost the same variable. So because of that, we are now running into an issue where our model is not running. So really important to take care of those issues at the front end. So I have two options here. I can either combine the relationship quality with the parent quality with these three here, or I can get rid of one of them. For the purpose of this practice today, I'm going to go to the most simple one and just get rid of parental quality time as a variable. So our new model is going to get rid of this one here, and we're just going to look at relationship quality and parental engagement on negative child behavior. So let's go ahead and fix our syntax for that. So we're going to get rid of this line. So we're not going to need that. We're going to get rid of parental quality time as a variable. And we're going to get rid of it in our use variable up here. And now our syntax is ready to go, and we can check out our new revised model. Again, one of the reasons why it's so important to take care of and check your assumptions, because if I had not done that, I would have gotten to that point and had problems with convergence and not understood why. So important that you do check your assumptions, otherwise it can cause a lot of headache later on when you get to your model. All right, so let's go ahead and check this model out. As we can see now, the model did terminate normally. We have 38 free parameters here. And so let's see here. We have chi-squared tested model fit is not significant. Again, large sample size, not too worried about that. Our RMCA is 0.04. Again, we want it below 0.08. 0.05 is great. And our 90% confidence interval is between 0.03 and 0.05. It's great. 90% confidence intervals. Our CFI and our TLI are strong. They're both above, CFI is above 0.95, TLI is above 0.93. And our SRMR is 0.036, so 0.04 when you round up, and we want that one below 0.10. So we're sitting in a good place with this. So I'm happy with these results. The next part here is your model results. These are the unstandardized results. So we'll see here, the factor loadings first, and then we'll see our regression, our main model here, and then we'll have the with statements and the intercepts, variances, and residuals. So we'll go ahead and go down the STDYX because this is what we're concerned, what we want to see most about. Now we can see that we do have significant findings in our model. And in fact, relationship quality is negatively associated with child negative behavior. So what this means is, we interpret this the same way as we do with regression outputs. So as relationship quality goes up by 1 standard deviation, negative child behavior goes down by 0.17 standard deviations. And as parental engagement goes up by 1 standard deviation, negative child behavior goes down by 0.15 standard deviations, and they are significant. We can see the correlation between these two variables. They're not highly correlated, even though it's significant. It's a 0.30. So it's a good thing we did keep those separate because they are separate constructs. The intercepts we don't care about. Variances, residuals, we don't really need that information. The R squared does tell us how much of the percentage of these variables is accounted for in the model. And if we look at, and it doesn't include in here our latent variables, which makes sense, but our model accounts for 6.4% of the variance in negative child behavior. So not a high amount. If we wanted to try and improve our model fit, we do have more things in here. They're going to be the same things we saw mostly from that CFA. This one should look familiar because that was in there. So I'm happy with these results for this course example. We can move on with these. I'm going to show you one more thing that I haven't showed you yet in M+. So if you remember back, I told you M+ has 3 file types. One of those 3 file types is the diagrammer. So if right after you run your model, you go over here and hit diagram and view diagram, it takes a moment to open, but once it does, now we have our diagram here. So you can see here it has our CFA written out and our main model here with relationship quality on negative child behavior, engage on negative child behavior. So this is a way where if you wanted to visually see your model, you can. Now if you go to the view option here, you can change what you see. So right now it's giving parameter estimates. That's the unstandardized. If you want to see standardized, just click on stdyx. Now it's giving us the standardized output. We can also ask to only show significant pathways. You can see they're all significant, so it didn't make any go away. There are lots of options for what you can see. We can ask to specify decimal places, so if we wanted to go to the nearest 2 decimal places, we can have it do that, and it'll automatically round for us. We can also change the font settings. So right now it's in Times New Roman plain 20. If 12 is what we'd want, but that'd make things really small for us to see here. So there are things that you can do in here. You can also ask it to show only estimates, so that way it gets rid of the standard errors, and that's a little bit even more clean in here. But what there isn't here is any place to actually see your actual p-values. Now you can say only show, significant, and that'll get rid of anything that's not significant in here. But this is how you can use the diagrammer, and you can again save this diagram file, and we'll save it right there in that same file. And then we have our diagrammer there as well if we wanted to keep this. So the next thing we're going to do is write up the results.